Spent e-learning graphing more cosine than you. You spent the weekend graphing tension too. We spent the late nights shifting it right then left. But now it's all graph, maybe. Roll that sine wave, maybe, and make me know that graphs like you run around with guys like me till sundown Trig comes through. I need a graph like you, yeah, graphs like you. Love puns and yeah, me too, to get the graph to view. I need a graph like you, yeah. May it now be known that my vocal range is not the same as Adam Levine's. That was a stress, okay. But I did rewrite the lyrics, and I'm not sure they're really that great. But I did it for you because you asked me to. Okay, so continuing on with what we were talking about today, we come to this definition of inverse sine. Okay, so we just got done going through why we needed to restrict the domain of the regular sine function so that its inverse would be a function. Now, what would this graph look like if I was just graphing the regular? So it looks like I have to go from -1 to +1. Okay, so that's the domain, and the range is here. So, in fact, I did a bad job of drawing my axis. I'm going to have to redo it. My goodness, I didn't leave myself enough room. That was a poor choice. Okay, so we want to be here. We want a -1. We want a +1. We want a -π/2 and a π/2. And so the inverse sine function, now remember, maybe I should just show you the picture of what the regular sine function was doing something like this, but the inverse, remember how we talked about how you reflect that across the line y equals x when you switch x and y? So it's got to have that mirror image shape that's doing something like this. So I'll erase the portion of the sine wave and just show you the inverse. So there's your inverse right there. Okay? That passes the vertical line test. That is a function. Okay? Now we can move to the cosine wave. Okay? So it's going to be a similar situation to what we talked about before. And so I'll probably zoom in. We talked about how you didn't like this graph or the vertical axis because it's not like what you're used to. Now, HK, which is sitting right here, is not a point on the cosine wave, right? So I have to go up using the maximum, and that's 1. We know that this is 1.57, so that's too high, so right about there, okay? And we can move to the right. We know the period of the cosine, so that's going to put me starting another place right there, halfway in between. We're down 1, so or below the center line, and then we can put our x-intercepts in here, and we can get this part of the graph drawn and this part of the graph drawn. Oops, going over my point here. All right, let's scoot over so we can get the rest of this drawn. So we know that 2 pi units later, it's going to be starting over, halfway in between, it's going to be down, and then we can find our x-intercepts. Okay, so there's our cosine function. What's the domain? You know, that kind of stuff's pretty easy for you guys. You know, domain is all reals and range -1 to 1. Okay, pretty common. And now what happens when we do the inverse cosine? Okay, well, maybe I should ask this question. I've got these other questions here. What does x represent? Remember that angle measurements are going into this function, just like we talked about inputs and outputs. So angle measurements going in. And what is coming out of the function? These cosine, when you take that angle measurement and you take its cosine, you're finding an x value. And I know some kids get all confused and they're like, well, it says y right there. Well, remember, I could use whatever letter I want. The cosine is the x value, and that's what we're getting. We're putting an angle measurement in, and we're getting x value out. It's really kind of important to know that, because when we start doing inverse cosine, we're going to put x values in and get angle measurements out. So if I understand what's going in and out of the original function, then I'll understand what's going in and out of the cosine inverse or the sine inverse or tangent inverse, those things. Okay, now we're going to graph the inverse, and just like we talked about in class, we're going to switch x and y. So obviously some things are going to, so this point right here is a point 0, 1. So now it's going to become the point 1, 0, which is right about there. All right, pi over 2 is 1.57. And then let's see here, pi over 2, 0 becomes 0 pi over 2, which is kind of right there. See if I can get rid of that circle. Yep, there we go. And then pi negative 1 becomes negative 1 and pi. So right about there. And then we get to 3 pi over 2, 0, which is 0, 3 pi over 2. And then lastly, 2 pi comma 1, which would be 1, 2 pi, somewhere about right there. And we could duplicate things on the other side. We know it's going to come down here. We know the next one over is going to be this. Then it's going to come back. And then eventually end up here. And I'm going to zoom in because I will do a poor job drawing this if I do not. So we can ask domain and range. Of course, hopefully, I'm guessing that you will understand that it is negative 1 to 1 and all reals for the range, because these have just switched places, just like with any other inverse. So now I ask you the question, is the cosine inverse a function? The answer definitely is a no. It fails the vertical line test. So we know that's a no. Right? Fails vertical line test. What if we restricted the domain on y equals cosine so that the inverse would be a function? Okay, so we're going to go through these three things again. The restricted domain has to have all the right angles, all the angles of a right triangle. It has to have, has to be continuous, right? So all the angles of a right triangle has to be continuous, and it must have the same range as the original cosine function. Okay, so if I go back up here and take a look at this, I'm going to be, so we know we're guaranteed to have this section right here in the green, because those are the right angles from the triangle. Now, if I do the same thing we did on the last one, I go backwards, right? I make a connected piece that goes back this way. So that's a continuous piece, the orange and the green. It does include the angles from the right triangle, but the problem is It doesn't have the correct range. I mean, look at the range of the orange and the green. That would be 0 to 1. I need to have negative 1 to 1. So that orange part needs to be erased. That is not a good piece. Let's see if I can do, there we go. Where should I go? I should add this chunk down here. Because now I'm going from a high value of 1 to a low value of negative 1. That's good. That keeps the range. It's continuous, and it has the... So what is that? So I'm taking from 0 to pi. That's I'm gonna cut off everything on the graph for the cosine function except that piece right there. So that, and if I do that, and let's take a look at what happens when we do that. Oh, stop drawing on the page. I'm trying to... No, I can't get rid of that dot. Oh, well. So, if we restrict the domain, if we cut this domain down to 0 to pi, that becomes the new range of the inverse cosine function. Now, what's that going to look like on the graph? So we went from 0 to pi. We got a 1 here and negative 1 down here. Something like this. Okay, that was our piece. When we reverse this, we come up with our inverse. It's going to look something, and because the scale is not correct, let's see, that would be 1.57, so it's going to be like start here, go through here, and come out the other side. So it would look something like that, okay, for your inverse. So the green portion here that I just erased was the restricted cosine portion, and that produced the red inverse portion. And now the question is this cosine inverse function, is it a function? Yes, because it passes the line test, the vertical line test. So that was the goal, is to get the whole thing restricted. Now, what do you have on the circle? If you're going to say from 0 to pi, where is that on the circle? Oh, not parentheses. No. Brackets. Where is that on my lovely handy dandy circle? That would be the top half. Okay? Now, it's starting to look like a really bad hairdo. Okay? I will tell you that that particular style of hair is called a comb over. All right? That's when guys are losing their hair. So they grow it out on one side and then they flip it over to the other side. It looks horrible when it comes out of the shower. It looks horrible when it comes out of a swimming pool. I would not recommend it, but I do know people that have used it for decades and still use it. Not me, folks. I'm going bald. I'm shaving it all off every time because I'm not going to waste money on something that I can't keep anyway. So that right there, 0 to pi. When we start talking about cosine inverse, I'm going to give you cosine inverse 1/2. Okay? That's a question you should be able to answer, and you're going to be able to look and say, well, it's an x value, and my answer has to be in the top half of the circle. So that is pi over 3. Those kind of questions I'm going to be asking you, and we'll be practicing them. But your answer, now, you know and I know that there's another part of the circle that has the exact same cosine. But the cosine inverse function has a range, and that range is from 0 to pi. You can't give me any other answer but between 0 and pi. Otherwise, you're wrong for the cosine inverse function. Because if we can have more answers like this one down here at 5 pi over 3, or you can call it negative pi over 3, one of those, it suddenly isn't a function anymore because you have too many values and it fails the vertical line test. Now, one thing that I forgot to mention, and I should have mentioned, was this back up here. This term, arcsine, so you might see this notation. I should have highlighted that earlier. It means exactly the same thing as sine inverse. I have no idea why we have two different, I should probably look it up, find out the history of it. It's probably two mathematicians that were arguing, over who was right and which one should be the best. And nobody could decide, so they just said, well, we'll keep both of them. I don't know. Personally, you don't see arc cosine and arc sine in a lot of other places. So you will see cosine inverse written that way a lot. Yeah, that's good. Okay, tangent. Let's graph this tangent function. And let's see where this goes. Hold on a second, I got to pause. Okay, so, let's see, what color did I use for cosine? Cosine was the blue, okay. So tangent, we'll use blue. All right, so we know that the regular tangent function has asymptotes on the odd integer multiples of pi over 2. And we know it's got x-intercepts at every integer multiple of pi. And so, these sections are going to look like this, right? Okay, so what's the domain? Domain is all reals except odd integer multiples of pi over 2. And then, of course, my range. That thing goes on forever and ever. It's all reals. Okay, so what does x represent? What's going into the function? Once again, angle measurements. What's coming out of the function? Slopes, right? It's not x's, it's not y's, it's slopes. That's important to know because when we do the inverse tangent, we're going to put slopes in, and then we're going to get angle measurements out. Now, what's the inverse look like, right? We're going to do that in red here. So the inverse, once again, is every one of these every pi units, because you're switching x and y, and the odd multiple integers or odd integer multiples of pi over 2, and you're going to get these x-intercepts every pi units, blah 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 blah. They go on and on and on, and so as it comes through, it's doing this. And it keeps doing that forever and ever and ever, but I just don't want to keep doing it. Now, if I look at those red ones, and I know that there's an infinite number above and an infinite number below, what's my domain? Well, of course, it's going to be the all reals, right? And no, I'm not going to write that all again. All reals except odd integer multiples of pi over 2. But the big question, is it inverse a function? Nope. Fails vertical line test. So in order to fix that, we need to chop off a lot of the tangent function. In other words, that restrict the domain idea. And then, if we go through the same set of rules, right? Same set of rules before. Must contain the angles of a right triangle. Must be continuous. Must have the same range as the original tangent function. Once we've got all those, then we'll know what we should have it restricted to. Okay, so if I take this green, so everything from 0 to pi over 2, whoops, don't move it around, lock it in place. That would be this green section right here. Now, if I do what I did for cosine, 0 to pi, that would include this section over here, 0 to pi. Now, why is that a bad idea? It looks like it has the correct range, right? Negative infinity to infinity, all reals. What's the major problem? It's disconnected. It's discontinuous. It doesn't meet that criteria for the continuity. So I'm going to get rid of that choice. Come back in here, pick a different color, and see if we go the other direction. Would that be a good choice? Well, let's see. It's got all the angles of the right triangle. It's continuous, and it has the correct range. So ding, 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 right there is what we're looking for. But there's a difference between this one and the sine inverse. Notice that it can't touch the asymptotes. So, maybe I should use a different color. Yeah, we'll get down here. When we get down here and we start saying, how are we going to restrict the domain? We're not going to do all reals. We're going to restrict it from negative pi over 2 to positive pi over 2. But notice the difference. I did not include the endpoints. So remember in the video way back up here, when we were doing sine inverse, where are you? Remember that I put brackets here, lock it in. I put brackets here and here because we were including those endpoints. Maybe we should use closed circles, if that would be better. But guess what's going to happen down here on the tangent inverse? Because I'm going to ask you, what's it look like on the circle? It would be an open circle. And everything all the way down to here. Everything. So, although it is the right side of the circle, with these kind of questions, now I need you to understand something here. I'm going to write these out. So every single one of these inverse questions, whether it's cosine inverse, sine inverse, or tangent inverse, can be answered by one of these. So for instance, this is negative pi over 2, and this is negative pi over 3. I know you're used to calling n 5 pi over 3, but remember, if I'm headed in the negative direction, it would be called negative pi over 3. And of course, that would be negative pi over 4, and negative pi over 6, and 0, and pi over 6, and pi over 4, and what's a bad looking for? And pi over 3, and pi over 2. Now those are the main ones for the inverse cosine, or inverse tangent and inverse sine. But inverse cosine went from 0 to pi. Remember that top half of the circle? So it would also have possibilities of 2 pi over 3, and 3 pi over 4, and 5 pi over 6, and pi. But guess what? All of these inverse questions are going to be answered by those choices. It's like a giant multiple choice question. I love it. Anyway, yes, we have things called inverse tangent and arctan. Okay, now I thought arctan was was like the fourth musketeer, but you know, I think that's probably not true either. But I thought it was funny. We're going to start doing these kind of questions, evaluating sine inverse without a calculator. Let me see how much material I have left in this. Okay, we're good. We got to keep going a little bit more. So sine inverse 1/2. Sine inverse 1/2. So we'll work on letter A right there. So this is a y value. Now, sine inverse is asking for an angle measurement theta. So we're only allowed, according to the inverse sine, remember the negative pi over 2 to pi over 2? This one included the endpoints. But my answer has to be on this half of the circle only. Okay, if that's the case, the y value is 1/2, and if my only answers are on this side of the circle, then the answer to this question, so for letter A, we have pi over 6. How about the next one? Letter B. Sine inverse negative radical 3 over 2. Well, so that's negative 1/2, and that's negative radical 2 over 2. So negative radical 3 over 2 is here. And if I have to go to the right, it's right there. But don't you dare call it 5 pi over 3, because that is outside the range of the inverse sine function. It would be negative pi over 3. Part C. Now, this one's kind of a weird one, folks. Sine inverse pi over 2. So they're telling me that the y value is pi divided by 2. Well, okay, so if I take that's 1.57. So wait a second. You're telling me that the y value is approximately 1.57? I thought the highest y value on the whole circle was 1. Now you're asking me about 1.57, which is off the graph? There's no answer to that. You're trying to trick me. No solution. Okay, so they're trying to trick me. There's no way to do that. I don't think I'm going to try to trick you like that either, but now, the sine of pi over 9. Pi over 9 is, what is that, 20 degrees? 180 over 9, that's 20 degrees. Okay, so pi over 9 is somewhere in here. It's not even one of the nice ones on the circle, okay? But the sine of pi over 9 is some y value, okay? I don't really care what it is. It's not even something, I can use a calculator and find it, but, what do I think it is? Like 0.4, something like that, 0.37. So I'm just guessing, folks, by looking at the scale. Then they ask me this question. What is the angle measurement inside of negative pi over 2 to pi over 2 that gets me that? Well, guess what my answer is? Pi over 9. So it really wasn't that tricky of a question. The last question here involves 5 pi over 6, and it starts with, so we know that 5 pi over 6 is over here at letter H. And the first thing you do is the inside part, which is the y value at that, which we know that's 1/2. So this question is the same as, let me pick a different color here, as this question. Sine inverse of 1/2. Well, guess what? You've already answered that question up here. We already know the sine inverse of 1/2. So I started out here at H, and guess what? It took me to the right half of the circle and landed me, so letter E landed me at pi over 6. Everything is being shoved to the right side of the circle. Everything. We need to practice more of those. Okay, that's why I'm having you do this video, is because they're not easy questions. And you're just getting started understanding this whole process. Now, can you take a calculator and type sine? Now, what's the key thing here? The key thing to this whole question is you have to switch your calculator over to radian mode or you're going to get it wrong. So you'd have to do sine inverse of negative 0.81. I mean, this is just a matter of typing, folks. So I'll switch my calculator over here. Let's see here. Mode, third one down, switch it to radians, and go back to the home screen. Sine inverse, negative 0.81. And it tells me that my radian, so my angle theta for letter A is negative 0.944. Okay? It's not going to give you an answer in terms of pi. So the next one, sine inverse of sine of 3.49 pi. And I got negative 1.539 when I did it on my calculator. Not something difficult for you. That concludes our video for today, and hopefully we can finish up the notes in class on Monday. I hope you liked my song, even though it's way out of my range, and I'll probably have to find something that's a little closer to my singing voice. Talk to you later. Bye. Okay, after looking at how much material we're going to have to cover when you get back, I'm going to have to do example 3, so I'm sorry for kind of lying to you a few seconds ago. Let's just do example 3, A, B, and C, and then we'll move on, okay? Find the exact value of the expression without a calculator. All right, so remember, we talked about how this is an x value. They're giving me an x value, and they're asking me for an angle measurement. That's the question. What is the angle measurement that gives me that x value? Now, you're only allowed to give me for the range of the inverse cosine function 0 to pi. Everything has to be between 0 and pi. Okay, so let's see here. Negative radical 2 over 2. Well, it's not negative 1/2. It must be the next one over, negative radical 2 over 2. And if I'm only allowed to give you an answer in the top half of the circle, it would be there, letter G. What is the angle measurement for letter G? Well, we know that. 3 pi over 4. Letter B, tangent. Okay, so this is tangent inverse. Okay, now, folks, they've switched the question on me. Maybe I should go to C first, because C is about x values too. So in here, they're saying, okay, the cosine, that would have to be a radian measure. Okay, so this is a radian measure angle. They're not trying to throw negative 1.1 degrees at me. Okay, negative 1.1 radians, which we know that's, about negative, 70 degrees or something like that. No, yeah, about negative 70 degrees, somewhere in there. I can't be too wrong. Negative 3.14 would be negative pi or negative 180. So somewhere in that range. Anyway, so if you're down here somewhere, and the cosine of that is an x value, right? But then it's going to take me to the top half of the circle. So what angle measurement is from here to here? Well, if this angle measurement was negative 1.1 radians, then the other direction would have to be positive 1.1 radians. Notice that they're going in opposite directions, but they have the exact same x value. Okay, now we can go back to B because it's a tangent question. The reason I want to, it's a tangent question, we have to think in terms differently, because remember the inverse tangent, that's over here on this side, not including the endpoints, right? Can't include pi over 2 or negative pi over 2. So they give me a slope, right? Radical 3, that's a slope. Those two right there have radical 3 as a slope. But since my answer has to be on the right side of the circle, it has to be this one. And that one happens to be pi over 3. So there is the answer to that question. So we need to practice more of these where I give you a y value, or I give you an x value, or I give you a slope, and you have to come up with the angle measurement inside the range of that specific inverse trig function. Okay, so we will practice more on Monday.